now for the best part. I'd like to introduce today's speakers. First up, we'll have Dan Prince, who is the lead engineer for Target Data Services, and he is going to be talking about their self-service Druid or self-service ingestion solution, which simplifies Druid ingestion for non-engineer users, followed by a talk from Vadim Ogievetsky, who's the co-founder and CPO at Imply, and he's going to be talking about data modeling. And then last but not least, we'll have Gian Merlino, who is the co-founder and CTO at Imply, and he is going to be presenting the latest and greatest Druid roadmap updates. So I would like to go ahead and pass the baton to Dan Prince, who's going to be kicking us off.
All right, thanks very much. I'll share my screen here. You guys see that okay?
You can.
All right. Yeah, thanks for having me. I'll get right to it here. Target, as most of you in the United States know, but for those outside of the country, we're a US-based retailer. We sell groceries as well as just about everything else. We have more than 1,800 stores across all 50 states. We're one of the top 10 e-commerce sites in the US and more than 300,000 employees worldwide, as well as, of course, partners and suppliers and supply chain all over the world. I want to go into a little bit, before I get into the ingestion piece, I want to talk a little bit about how we use Druid at Target. We have a thing we call the Enterprise Analytics Platform. My colleague, Jeremy Wolfel, who's on here tonight, he gave a talk at last fall's Druid Summit that describes our platform in detail, and I encourage you to check it out. It's it's a really good overview of everything we're doing with Druid. I stole a few of Jeremy's slides just to begin with here to give you an idea of what our system looks like, and then I'll go into our ingestion tool in a little more detail. So what is this Enterprise Analytics Platform? Well, this is what we used to have up till a few years ago. Kind of your standard data warehouse. We feed data from relational databases all across the enterprise into the data warehouse. We have a reporting tool sitting on top of it. And then analysts run SQL against it. Pretty standard fare. Nowadays, we've really transformed that into this, which many of you will recognize also. We have a big data lake hosted in a large Hadoop cluster. We've got heterogeneous sources of data from all across the enterprise being ingested into there. And then on top of it, we have this thing we call Enterprise Analytics Platform. And the goal of the platform is to sort of democratize access to the data that we collect from all over the enterprise. And in particular, we try to make it available to people across the enterprise, regardless of their technical skills. So a lot of people using the platform, they're not engineers, they're not necessarily even data analysts. And we also are developing what we call certified data sets, which are run by, sort of maintained by engineering teams with a very high level of quality and up-to-dateness. And our platform ends up being sort of a forward cache for the data in those data sets, and it allows data exploration across those. here's a little bit about the architecture of the platform. As I said, we've got our data lake over here. It feeds into Druid. We have a MongoDB cluster that we store the platform metadata in. Information about the data, but also users and groups and permissions and so forth. And then the REST API that we've developed as sort of the middle layer is really a query generation engine. So the users in our React UI can formulate business questions, and then we translate those into Druid JSON queries. And then the API is also available throughout the enterprise for other tools to hook up to. So what does our cluster look like? We run hundreds of nodes in our Druid cluster. They run in our own data centers on our own hardware. We're running Druid 18 and planning to upgrade to 20 in the next month or two. Hundreds of historical nodes, multiple brokers that are load balanced, more than 10,000 cores in the cluster, hundreds of terabytes of RAM. We put our deep store in HDFS and MySQL for metadata, and over a petabyte of storage all told. We have more than 3,500 data sources, over 3 trillion rows and counting of data loaded into here. Interesting fact about the sizes of those data sources, more than 3/4 of them are really small, less than 1 million rows. And although we also have some pretty big ones that are well over 10 billion rows, but that's a small number. So a lot of this sort of democratization is happening with real small data sources, and that influences the architecture of our ingestion system, which I'll talk about in a sec. So batch ingestion into this cluster. Why are we doing that? Batch seems so 2015. Why are we investing in building a tool for batch ingestion into our Druid cluster? We are doing a lot of real-time ingestion into the Druid cluster as well, and that's growing. But we don't believe it'll ever really replace batch ingestion. We've got a lot of relational databases across our enterprise, and we probably will for a long time into the future. We've got a lot of data sets starting to leverage this Lambda pattern where we do both. We do real-time ingest into the data set, and then we have scheduled batch jobs that restate the data that needs to be corrected or maybe fill in historical information. So yes, we're doing real-time, that's growing, but a batch will be around for a while, and it's growing as well. So luckily, Druid seems to work really well for both of those for us. Little note about where the data comes from. Close to 40% of it is coming from the data lake, as we mentioned. Most of the rest is from relational databases all around the target community. We also have a decent slice of it that is coming from our DB2 mainframe, talking about technologies that don't go away as soon as you think they will. And then we offer support for ingesting flat files from all kinds of sources as well. So that's where our data is coming from. So the ingestion tool, what are the requirements of this tool? Well, this goofy guy once said that everything should be made as simple as possible, but not simpler. And that's what we've kind of adopted as the philosophy for this tool to get data into our Druid platform. The basic idea is we try to hide the complexity of the various Druid-specific concepts that you would otherwise have to know to get your data into Druid, so that non-technical users can set up an ingestion job and get their data in without having to necessarily learn about granularity and the time series column and metrics and dimensions and how data is stored and how schema is handled in Druid segments. The different indexing methods you can do with ingestion, like the native within the Druid cluster, parallel native, and then indexing using the Hadoop cluster. So we try to hide all this, but at the same time, we try to let knowledgeable users or users with complicated use cases to get into all those details when they need to, in order to have a good data source that query that'll have good query performance. So we also need this tool to scale and perform efficiently. We are ingesting close to 60 billion rows a day. We average over 6,000 jobs per day into 2,200 different data sources, and hundreds of different users are building those jobs. Here's a shot of what the ingestion tool architecture looks like. So we have a UI up in the left corner there. The user can set up their ingestion job, which then gets scheduled to run on a daily, weekly, monthly basis. What the user needs, the minimum sort of that the user needs to give us when they're setting up their job, connection details for their database, and then SQL to run to pull the data that they want to pull out of that database. So this example here is showing a relational database that we're going to run SQL against. Another common use case, as I showed earlier, was just the data is already here in our data lake, and we run Hive SQL against it. But for this use case, what happens is we run the user's query, we stream the data out of that data source, and we stage it in HDFS in our Hadoop cluster. So that's the first stage of the ingestion process that I've got diagrammed down here. We stage the data, and by the time we've done that, we understand what the schema of the data looks like and the size of the data, how many rows they're ingesting. And from all those things, we can make a lot of decisions about what's going to go in the Druid ingestion spec. And in a future slide, I'll go over the details of how we do that. But we generate the ingestion spec on the fly based on that data. And then we kick off the indexing job in Druid. And while that indexing is happening, either in the Druid cluster natively or in our Hadoop cluster, we go into a polling loop, the Kubernetes process that is orchestrating this, just sits and waits for that indexing to complete. And once that is done, we go into the phase where Druid, the coordinator in the Druid cluster, needs to propagate the segments throughout the historical nodes in the cluster. And so while that's happening, again, we're polling to wait for that process to complete. And then we have various notifications that go out that, depending on how the job is configured, that say, hey, your data is now ready to be queried. And that's why we're waiting for that propagation to complete, because when this job is over, the user expects to be able to go and look at their data. Here's a little bit of the detail about how we generate the ingestion spec. We categorize the columns into time series and metrics and dimensions. For the time series column, we scan the columns left to right in that staging table and pick the first one that's a date or a timestamp. Floating point numbers, floating point columns are categorized as metrics, and strings or dimensions. And then for integers, they could often be both. And so we have naming conventions where the user, when they create their SQL, can name their columns appropriately to indicate which, whether that integer column is going to be a metric or a dimension. So for example, they might say location underscore ID. We look at that and we know it's an ID. We know we're not going to aggregate that, so that's a dimension. They could say sales underscore AMT. And so we know that's an amount, and that's going to be a metric. And then we have what we call in our tool replace mode, which is a fancy name for just setting the granularity to all. And we only do this for those small data sets that I mentioned earlier, which is more than 3/4 of our data sets. But this leads to because only a single segment is created with that granularity, then all of the data in that data set is replaced on every ingest, which it turns out it's a common use case among our users. And so that's an easy way to affect that. We also choose the indexing mode, whether we do it natively in Druid or in our Hadoop cluster, based on the number of rows that they're ingesting. We prefer to offload most of the heavy lifting to our Hadoop cluster, so that we save the power of Druid to make our queries really fast. And so, but for small data sets, it doesn't put too much stress on our Druid cluster, and it's a lot faster. So, and then, of course, as I said, users can override all of this stuff depending on their use case. I mentioned that we do these polling loops where we're just waiting. And in addition to just waiting, we are ingesting the logs from those processes, from the initial Hadoop Hive query, potentially, if there is one. And then we ingest the logs from the Druid indexing process. And then we do this polling to monitor the segment handoff. And we capture those logs to make it easy for the user to figure out what happened with their job. We also have a parser that kind of greps through those logs and detects common errors. And so then we can pop up a little window for the user that says, hey, we think you did this because we've seen this error before, and here's how you fix it. This process of polling the segment handoff is somewhat inefficient. And we have a proposal into the Druid community about a way to make that more efficient, which I'll get to in a sec. We also do this thing we call a circuit breaker to protect our cluster from getting clobbered by a giant ingest job. And so If a job is going to create too many segments, we abort the job. And that's because the main bottleneck we discovered in ingesting all this batch data is this segment handoff from the coordinator to the historicals. It turns out if you've got a lot of segments, even if they're very small, the coordinator will struggle to get those handed off. That's one of the problems we've encountered along the way. A couple other ones, the polling to determine when that segment propagation is complete. The specifying of the ingest intervals before the job starts. We usually end up letting Druid do that as a result, because we found it difficult to have a useful user experience where the user can accurately specify that. And then secondary time series columns are a feature that has been much asked for among our users, and we've been getting into that recently. It's gotten us into more complex partitioning to try to make that secondary time series column perform well in queries. And we ended up patching the arbitrary granularity extension for queries in order to implement our fiscal calendar in queries. So that was an interesting way to get us into the Druid code base and to submit back some code changes. Speaking of which, for future enhancements, my colleague Lucas Capistran at Target is a Druid committer, and he's got several PRs out that we are working on to fix these problems that we've come up with. One of them is to speed up the segment propagation, a more efficient method of polling that segment propagation process, putting that circuit breaker function into Druid itself so that we don't have to do it by grepping through logs. And then we have some other features that we're working on internally to sort of democratize this ingestion platform so that more people across Target can use it. There's the link to Jeremy's talk about our platform. I encourage you to check it out. And I'm a little bit over time, but that's all I've got. But there is some time for questions if anybody has any.
Hey Dan, this is Shri, and I'm from Intuit.
Hey.
So I had a can you elaborate a little bit on the API you used for parsing the Druid queries? I'm interested to know about that. Is there any link to it?
You're talking about the query generation engine that I spoke about?
Yeah, in the first initial slides you had.
Yeah. You know, that's entirely in-house developed in Target. So we don't have any documentation on that. It's really the meat. It's sort of the secret sauce of our platform, and we've put a lot of work into that. There may be opportunity in the future to open source some pieces of that, but at this point we haven't. So I can't point you to anything, unfortunately. Sorry about that.
No, thank you.
Dan, looks like we have a question in the chat box, first from Arthur Sherman.
That was just a comment on, excuse me, on the query generation.
Cool.
Hey Dan, I just wanted to say that was a really awesome talk. That's really cool. It's
Thanks.
this is actually reminding me a lot of some stuff that we haven't actually shipped yet at Imply, but we're in the works on that's trying to solve a lot of the same problems that you've solved internally at Target. So this is really cool. One thing that I thought was really interesting, you said 3/4 of the tables are small, less than 1 million rows. You know, I usually think of Druid as something that's really great for large tables, but what kind of stuff are people doing with these small tables?
You know, a lot of them are sort of lookup tables and that kind of thing. But we do see a use case that's really common where somebody will ingest even just a few thousand rows of their data and then play around with it in the platform to kind of gauge whether it's going to work for them before they make the investment of ingesting a bunch of stuff. Other than that, I can't really characterize what that data is. Jeremy, feel free to jump in here if you have an idea about that.
Sure. Yeah. I mean, so certainly some of our data is deep, right? The sales, transactions, inventory records, that kind of stuff. Those are the tiny slice that Dan showed in the pie chart. Some of the stuff is just, other business areas that maybe just don't have the breadth and the depth of the data. So things out of maybe our facilities management, right? Might only be a few million rows. Places in finance maybe don't have the depth. The thing is, we use Druid and we use this platform for pretty much all areas of the business. So with the nearly 4,000 data sets that we have in there is a substantial amount that just don't have a lot of record depth to them.
Yeah, that makes sense. Are people usually interacting with Druid through a particular application or BI system, or do you have like a whole variety?
Yeah. Sorry, Dan.
No, that's great. Go ahead. That's right.
Oh, jeez. I'll take that one, I guess. It's all through this analytics platform that Dan mentioned a few times. So we don't really expose Druid to everybody. Access to it is through thank you, Dan, the API layer and the UI layer over the top of it. So it's a point-and-click web app, and then there's a few folks just consuming Druid data through our REST API.
Cool. I mean, I'm sure I could keep talking forever, but I don't want to hog the Q&A, so I'll keep my mouth shut. But thank you.
Yeah, thanks, John.
Hey, Dan. I just wanted to ask, so it looks like you're automatically generating ingestion spec for batch jobs, but are you doing the same thing for streaming jobs or real-time ingestion as well?
That's a good question, and we're not yet, at least. For those, we still have somewhat of a manual process where we write the ingestion spec mostly by hand, and then check it into version control. And of course, it's that's something that once you set that up within Druid, it's pretty much static as the real-time data flows in. The batch thing, we're actually generating that ingestion spec every time the job runs. So we can adapt as the schema changes or the size of the data changes and so forth. But yeah, we haven't gotten into automatically creating the spec for real time.
Okay, thank you. And just curious to know, among the data that you are ingesting, what is the split between streaming data versus batch processing?
The number of batch data sets is actually relatively small, but they're some of our largest ones, as you might expect, because there's a constant flow of data into them. I don't have numbers at the tip of my tongue. Jeremy, if you do, chime in. I'm not sure about that.
I think we maybe said that backwards. So batch is the bulk of the data sets. I mean, right now it's probably 95/5, right? 95% batch, 5% real time.
Okay, yeah.
Oh, okay. Cool. Thank you. Thank you, guys.
Dan, we have a question from Andy in chat. You've mentioned that you use Hadoop for larger data. Is the Hadoop cluster used exclusively by your team, or is it shared with other teams? We intend to use native ingestion as much as possible to avoid hogging shared resources on Hadoop.
Okay. It's definitely a shared cluster. It's the same cluster that we host the data lake on. We are very careful about resources in that cluster. And so for any sizable Druid ingestion job, we set up a dedicated yarn queue for that job so that it's not taking over the cluster when it runs. But we have actually sort of, and I think I mentioned, we've kind of gone the other way from where you are, where we try to protect the resources in our Druid cluster, and we shift a lot of the heavy lifting on batch ingestion into our Hadoop cluster. So hopefully that answers your question.
Yep, thank you.
Any other questions for Dan?
Hey, Dan, this is Sriram from Intuit. I'm sorry, I have a quick, maybe a basic question. You did say that you setting the segment granularity to all makes the tables all right. Is that correct? So that you have only the latest version or the latest copy of the data available at any point.
That's right. Yeah. Not in every case do we do that. Certainly, there's it's also common to have a daily job run and add a daily segment every day to a data set. But yeah, we do a lot of that all granularity.
That's the segment granularity, right?
Right. Yep.
Okay, gotcha. Thank you.
Yeah.
Looks like we have another question from Karthik. How long does a query run on Druid and is available in UI? Is there any lag, or is it more than X seconds?
Well, most of the queries we run on Druid are, I'm going to say, under 300 milliseconds for sure. It's rare for one to go over a second. It does happen certainly at busy times and with complicated data schemas and big data sets. I don't have numbers at the tip of my tongue, but we try to keep all the Druid queries to under a second for sure.
And Dan, maybe to address one of the other questions, you could talk about timeouts and sort of the time allocation we give to Druid queries.
Yeah, well, Mike, you know more about that than I. Feel free to chime in.
I was just going to say Jason actually, well, we allocate a minute for a Druid query to complete all the Druid queries for a card or report, and if they don't, the customer gets a timeout and is asked to filter their configuration, which can be frustrating, but it's better than having things run for days. And then Dan and Lee and team also built a sort of async Druid querying and card download capability where we offload cards that people don't need to see real time in the UI.
Hey Dan, it's Malik here from Walmart. So do you guys use any pagination on the front end, which is driven from your Druid queries?
No, we don't. We do set a maximum limit, at least for most of the reports that we generate, of 30,000 rows. And so we'll just load all of those into memory. When they get to be much larger than that, except for certain exceptions, then we use what Mike's talking about. We say you have to, if you want this data, you'll have to do this sort of batch export thing that we have, which then is an asynchronous process.
And probably a topic for a different talk someday.
Yeah, for sure.
Okay. And what level of aggregations you guys you have in the queries? You know, it's kind of a, you know, group wise I'm asking about.
Yeah, it's all over the map. You know,
Okay.
we do thousands of Druid queries per second, so you see everything for sure.
It's like a month over month or week over week. I'm talking about the batch queries. Like, you know, what are the time range maximum you guys have?
Yeah, certainly the majority of the reports that people generate on our platform are going to be you know, daily or weekly, but it's certainly not unusual to have you know, what are the, you know, what's the data from in a real-time ingestion scenario, you know, what's the data from the last hour?
Yeah, one last question, if you don't mind. So what is the maximum active data set you have on the Druid one can query, like in terabytes?
The size? Jeremy?
Yeah, I don't know. I mean, there's data sets that are probably in the double-digit terabytes range, and I actually don't know about this.
Okay.
The bulk of the data sets are small. There are a few that are.
The reason I'm asking is our data sets are huge, and we see most of our queries time out, you know, when users go year over year analysis kind of a thing, you know. So I'm just asking.
Yeah, for folks in the retail world, right? Year-end summaries are really important.
Yeah, I mean, especially when time comes close to Thanksgiving, somebody wants to do analysis from, you know, that's it. We have a big problem.
Yep.
Great. Well, thanks, Dan, for the awesome talk. If you have a couple minutes, there's a couple of questions waiting for you in the chat box. But because we're a little short on time, I'm going to move on to Vadim's talk. And we will be sending out the link to this recording so everyone can listen to Dan's talk, and you can share it with colleagues who weren't able to make it. So next up, we've got Vadim, who is our original OG Druid. He was actually the first Druid user in the universe, as I've heard him quote in one of his past talks. Today, he is going to be talking about data modeling, and I believe that he might also have a demo to share. Welcome, Vadim.
Hello, everybody. Thank you so much for having me. And I don't have just a demo to share. I only have a demo to share. I thank you, Dan, so much for your talk. I think my talk will really jive nicely. We're really forming a theme here of loading data into Druid. And I think one of the things I really appreciated about your talk, and I just want to highlight it for everybody, is that you had, like, in your slide deck, one of your early slides was really just like stating the objectives of your UI and your system and why you created it and what, like, are your goals and what aren't your goals. I didn't prepare any slides, but if I had prepared a slide, I would only have prepared one slide, and my slide would have been stating the objectives of what I'm about to show you. I'm actually gonna take you guys, everybody, on a little tour of the new stuff coming in the web console. So there's, you know, we're working right now on releasing Apache Druid 0.21, and there's lots of cool changes, a lot of them visual, a lot of them in terms of UX, and a lot of them, well, the ones I'm going to talk about are going to be in the actual console UI that I'm sharing on my screen right now. And as as we all know, well, or I hope some people know, the console includes a data loading wizard inside of it. That's part of the console, part of Druid. It's what you get when you download the Apache distribution. And it has like a very different mission to Dan's tool, the UI that you were talking about, because even though they're both written in React, the spiritual mission of the console is actually to educate people about Druid concepts and really to put them forward, to not have any or as little as possible dress up around it, to link to documentation whenever possible, and to serve as like a living manifestation of the Druid documentation. So maybe as in the process, well, I would have loved to see a demo of your UI, although I'm sure it's proprietary and not something you want to share too much, but kind of like to see the difference between these two concepts kind of manifesting themselves. So first of all, now onto the talk. What's new in the console? First of all, I hope there's people with a keen eye. I know Druid is a backend tool, and most people in the audience are like backend developers who, for whom a UI is just a small box and a big diagram. But look at the new styling. This has nothing to do with data modeling. We just had a reskin for the console. We updated all the colors, and I actually dug up this old cluster. So this is a cluster that thanks to, this is a cluster I found on one of our Imply cloud instances. This is running Druid 0.20. This is the current Apache official release. And this is using the default styles of the Blueprint.js, which is the library used to make this console. And we just went over it and polished the visual styles, made it tie to the logo a lot more. And I mean, styling and kind of like what I'm showing you now is very subjective. It's in the eyes of the beholder, but to my eye, I can't look at the old stuff anymore. Like, it's just like, I'm like, get it away. And the new stuff, like these new colors, like if you look at the SQL editor here, let me just pull up a query here. Oh my God. I mean, the colors just kind of pop and sparkle. So thank you for indulging me and just checking it out. It's one of my favorite changes. And now onto the boring stuff about how you get the data in the right shape in the Druid. What I really wanted to talk about is actually I wanted to showcase two interesting features. They're kind of like Druid Life Pro tips. They're things that were in some way possible before. If you're running Druid 0.18, I think everything I'm going to be talking about is possible then, but a lot of it has been exposed through UX. And again, the point of this UX is really to teach you about Druid more, and hopefully this will teach somebody. So I'm going to walk through two interesting concepts in data that got slightly better UX in this release of Druid, in this upcoming release of Druid. First of all, I wanted to load some data. And my data looks like this. I'm going to just paste it from another window. Well, I'm just going to apply it with the inline data source loader. I don't know if then in your system you have such tiny data sources that you can copy paste them into the browser, but we support it here because it's so useful for debugging. An interesting thing about this table, this data, is that there's a couple of columns here. It auto-detected the CSV, and we see that the date is in one column, and then we have time in another column, and seconds actually in a third column. I mean, I just made this data up, but you might think, oh, why did you contrive this? This actually happens. You actually come across real data sets where some maniac split up the time and the date, like they're two different things, and put them in two different columns, sometimes three. Sometimes people separate it into day, month, year. I don't know why people do it, but I'm here not to judge, although I do judge, but I'm not here to judge. I'm showing you how to work with this data. You know, when you go to the next tab here, it's the stage of the data loading where you need to figure out and specify the time column. It goes through, so the console will go through and detect date, and it's like, oh, cool, let's use date as the time column. Let's parse that. And you can see the preview here. It's the live preview. Seems to be parsing it correctly, but you know, I want all the information to really be packed in there. So now there's a cool thing you can do. There's this new button called expression right here. For just for contrast, if I just so you should believe me that this is new. If I do the same in this slightly older Druid, there is no expression button. If you click the expression button, you can actually specify an arbitrary Druid expression to dig out and figure out what your time column is. And there's actually like a little auto-suggest thingy. And oh, as it happens, the first auto-suggest happens to correspond to exactly what I need. Well, not quite, but almost what I need. So if I click apply, by the way, this isn't auto-detected or anything like that. I always call them date and time, and in the example they're date and time, so it just worked out. And now, what happens here is that we specified an expression, time parse, and then we concatenate the date with an empty string, and then with a single space, sorry, and then a time column, and then we parse that. And that, as you can see here in the preview, is giving me the correct. So you can see it's taking the information from the date and the time right here. Very nice. What's actually happening under the hood, as you know, like Druid, when you ingest data into it, you're writing an ingestion spec. This is actually writing this into the ingestion spec in the background. And it's doing a contrived little trick that is kind of like a life pro tip in Druid, which is you can set the timestamp spec to be just like ignored. You see it's telling it to parse from no such column, but then it's adding a missing value, so it doesn't actually throw an error. And then specify a transform to with the name of __ time that will yield a millis. That would be the time. So this expression will give me that millis, and everything would work. In here now, I can see a live preview that works. But wait, there's more, because I want the seconds column to be incorporated into that also. Well, it's pretty simple. So I mean, I have the date, I have the time, and to get the seconds in there, I guess I could just go in, add also concatenation with a colon to make it into like a standard format, and then seconds, and let's apply that for a preview. And we can see that the seconds column is now being pulled in as well into this preview. And you can do a lot of things with this. Again, the UI changed. The functionality of putting a transform with the name time hasn't, but it's now a very convenient shortcut with a preview to do this. Other things you can do with this is parse completely arbitrary formats using, like you can provide the second argument to time parse, which is like any JOTA time date format string. You can concatenate, well, I guess 3, 4, 5, 17 columns together. I think it would be pretty interesting to find a data set where the single date information is somehow spread across 17 columns, but I would not be too surprised if somebody actually was like, oh, this is my data, you just described it. And then one other really cool thing is that the third argument to time parse is the time zone. So if you have a data set where you have date, local time dates, and then like another column that like says what the time zone is, you can actually do per per row time zone parsing, which is just pretty cool. And again, the rest of this flow works exactly the same. So there it auto detects everything and asks me to pick a segment granularity. And if I didn't know what it is, I could learn. And yeah, they'll have a good name for it. And that's it. Now I submit this and it will work. So that's a very convenient thing, especially if you, you know, are in a mode where you're just kind of like given some data and you need to like onboard it. You know, a lot of our, at Imply, a lot of our sales engineers go to customer sites and they get given, you know, some whatever data and they need to get it into Druid to demonstrate how cool it is. So this is a very useful feature for that. If you just want to throw some data from an online example, one of my favorite data sets actually is the FAA flight arrival delay data, and that has a date and two time columns like arrivals and departures. You can pick which one you want to put into the timestamp. So that's a fun one. And I think this inline test finished. So if I select it right here, I can see my time parsed exactly as I wanted to. And in this case, I just clicked next, so it kept in the original date and seconds and time columns, but I could have just removed them if I don't want redundant information in my data set. I just didn't bother to do it. So that's one trick. And that showcases the expression entry field that's now in the console, which provides this real-time feedback. And again, when you're writing these expressions, it's really convenient to have real-time feedback, because if you mess it up in any way, you're just going to have like everything parsed to zero, which is how you know you messed something up and you need to revise it. The second thing I wanted to talk about is a different kind of example. So I'm going to start with the example data set now, which is the Wikipedia example. And I'm going to accept the defaults here. I don't want anything fancy regarding time. And no specific filter. And so it auto-detected some schema for me. The thing I wanted to talk about is this notion of partitioning. And this screen has been really cleaned up in this release. Cleaned up in the sense of like just the UX fairy has like spread its fairy dust all over it. Actually, it's both the partition and the tuning screen. Hold on. Let's see it. The tuning screen now looks like this. In the previous version of Druid, the tuning screen, let's get to it. Select something here. Looked like this monstrosity. So it's been really cleaned up. There's now this nice folder, so you don't have to worry yourself about all the things you really don't need to worry about, and only need to focus on the things that it's above the fold. Probably 99% of the time, you don't need to open this more. But let's go back to this partition step and talk about interesting partitioning. So what is partitioning? Partitioning is how you take your data set and you split it up into multiple segments. If your data set isn't so small and trivial that it can fit into one segment, then you're probably going to be splitting it up somehow according to segments. Primarily, you're going to be doing it by time. So enjoy the first order of business is to split your data up by time by some segment granularity. So you can say, okay, I want every day to be in a different segment. But even then, you might still have more data than can fit into one segment, even on a per day basis. And then you will split the segment up like a second time, like within a day, you'd create multiple segments. And how you do that is the secondary partitioning. So one thing that you could do is, so the default is dynamic. Dynamic just means just do it. Just like whatever, just first chunk, first this many rows, put it in one segment, next this many rows, put it in the second segment, and et cetera, et cetera. So that has a really cool speed advantage, but it's pretty boring otherwise. It's just like kind of arbitrary. And an interesting one I really want to talk about in this talk is single dim. Single dim means split it up by a certain dimension. And right now, I have a nice drop down here that lets me pick my dimensions. So I'm going to pick channel. And the use case here is if you imagine a data set where you have some form of multi-tenancy. For example, you have a data set with many accounts, like account IDs or something like that. And when this data set is accessed from your UI, it's going to be accessed like for a single account ID at a time. Like maybe you have you have thousands of clients, and each client gets like a UI that like looks at their account ID. So like each of the queries that they do has an implicit filter under the hood. You add a filter of like account ID equals like 1, 2, 3 for each client. Then splitting up the segments by account ID will give you huge performance gains because when you filter on like, if like most of your queries come with a filter saying account ID equals 1, 2, 3, then if your segments are partitioned by account ID as a secondary partitioning, then Druid can just straight up ignore any segments that don't have that account ID in it without even opening them. It's like they're in a different data source altogether. So in this case, I have this data is Wikipedia, and edits on Wikipedia, it's like the default data set. One of the dimensions is channel, which is like, language of Wikipedia is it? Like English, French Wikipedia, German Wikipedia. And I can imagine that I'm like working for Wikipedia and building a UI where like each language will be able to go and see how people are interacting with it. But like 99% of the access is going to be for a specific language. So in this case, it makes sense to split up by channel. Now I see I selected channel here. I actually get this warning label here, which is that I'm like in a weird inconsistent state. So the console is trying to teach me something here. It's a teachable moment. What happened is that in the configure schema step, I didn't touch it at all. So added is my first dimension. This dimension list is an arbitrary in Druid. Druid will actually sort your data according to the order of these dimensions. So first by time, then by added, then by channel, then by city name. If I select channel as the partitioning dimension, there's absolutely no use case under the sun why I wouldn't also want that to be the primary sort dimension. There's a whole blurb in the Druid documentation about why these two go together really well. But who takes time to read documentation? Well, maybe you take time to read a big yellow warning box and an actionable one. So one action is put channel first in the dimensions list. I can click it, the box goes away. It went away because if I went to this configure schema, now channel is first here. And one of the cool things that was added is this ability to reorder dimensions in this view. This is exactly to support to this kind of use case. So I could here make country name first. Now country name is first. I go back to partition. Now it's complaining again. It's like, oh man, you're partitioning on channel. Country name is first. That doesn't add up. Let's put channel first again. Let's leave it at that. And let's do max rows per segment. I'm gonna make it 5,000. This is comically low. This is a comically low value. Never make it 5,000 unless you are having fun. And if you are having fun, you can do whatever you want. I'm having fun right now. 5,000, this whole data set is about 23,000 rows. So if I made it any normal number, it would just go into one segment anyway. So let's make it 5,000 and let's see what happens. So let's call this wiki by channel, and generated my spec. submit. And there it is starting the ingestion. And we'll see some more things that were built around supporting this, this use case specifically. Let's just wait for it to, let's see, probably. Oh, this is interesting. Notice that by default, this view is filtering on the, not on the task ID, but on the group ID. When you're doing this ingestion like I just did, there's actually many phases to it. You get, like, you have to pay a price for the awesome performance you're going to get later. And the price is that it will take more resources, because it has more stages where it needs to shuffle the data and also determine the ranges and do all this kind of stuff. And you can see all of those phases spinning up, and some of them succeeding, and then some of them starting to run, and then you see all the phases kind of materialize. I encourage you to play with it. So they all are going to be under the same group ID, and that's why this view is filtering on group ID, so you can really see all of the phases of ingestion that went into making this work. So now that this is successful, I'm going to go to the data source view, and I see my segments haven't been loaded yet. So there it is. Okay, wiki by channel, 0% available. This will change in just a few seconds. But until then, I just want to talk about all the cool new columns here. So there's a new column for segment granularity. So you can now see the segment granularity of your data source. It will also tell you if you have a data source with a mixed segment granularity. You have segment sizing right here. Okay, so my wiki by channel loaded, and I can see that, let's see, I can see that it has 4 segments. And if I go to these 4 segments, there I have them. And these segments are still populating in the metadata. So these zeros will in a second become actual numbers. And I can see that the partitioning for them, again, this is a brand new column that was added in this release to make this flow that I'm demoing to you much more natural. The partitioning is single dim. So I know, okay, this is a single dim partition data source, and that's pretty useful. So as you know, all of these views that I have here in the console, they're all powered by Druid SQL, which is Druid's, like by the system tables. So if you ever see a view and you're like, wow, partitioning, I'm so excited that this column was added. Maybe Dan, you're looking at this demo and you're thinking, gee whiz, I really should like incorporate this partitioning thing into my data loader. But like, how do I get this information out? Well, very simple. You just go to like this whole console is open source, but beyond that, it's also very openly designed. In any view, you can click on this ... view SQL for a table, and you'll see the actual SQL query that went into generating this table. You see the trick that's used to figure out this granularity. You can see the how the partitioning is being determined. And if we just remove this like case, let me do that. If we just remove this case expression and just look at the shard spec column, that's again, the formatting of it is new, and I run that. I see the shard spec is coming out, and it says single for single dim, and actually it gives me a little bit more information here. So I can see that I have one segment that goes from like the start of the null, like nothing, to EN Wikipedia, and then one that goes from EN Wikipedia to Italy Wikipedia, and then there's Italy to SH and SH to the end. So Druid, when you go to Wikipedia by channel, and if you go and let's look at like the channels, let's remove the filter. So we're looking at some channels. Maybe if I filter on a specific channel, right, like so, when it does this query, even though there are 4 segments, it only needs to hit one of them, because it can figure out which segment this will belong to. Now, this data set is so tiny that I can't possibly demonstrate any performance gains, but you're welcome to try it on your own data set and see, this literally can, depending on the distribution of your account column, this can have enormous gains on your performance if you're always filtering it. So, and lastly, I should mention that if you are doing, the partitioning option that I configured for the ingestion, that's only available for batch. If you're doing real-time ingestion, then you go through the ingestion without partitioning, and then later you can specify compaction. Compaction is like is like the old defragmentation jobs we all used to run on our Windows 95 computers. Basically, it's a background task that will go and clean up the data source in some way. And in here, you can actually go and you can tell it to do single dim partitioning. So if you were doing this as a real-time data source, you would just ingest it. It would just end up in Druid. It would be naturally partitioned in the same way that your Kafka or Kinesis topic or stream is partitioned. But then the magic compaction fairies can do their beautiful work in the background and repartition your data after it's already ingested into something with single dim partitioning. So that's my demo, and I hope you enjoyed this tour of 2 live pro tips for the web console.
Great stuff from Vadim, as always. I know Gian's been answering some of the questions you've been getting over in the chat box. Thanks, Gian.
Yeah, I haven't been looking at the chat box.
No
Is there anything I should?
Hello. Gian had under control. Does anyone have a question they want to ask Vad really quickly before we move on to Gian's talk?
Yes. Hello, nice to meet you. I'd like to do a question here about multiple joins. How do we work with in situations that require multiple joins in Druid? Is recommended to use Druid for this kind of stuff, or not encouraged to use Druid for multiple joins in using 2 or more, 3, for example, data sources? Please.
That is an excellent, sorry to interrupt. I was gonna say that's an excellent question that if Vad answered it now would scoop part of what I'm gonna talk about in my talk. So just sit tight for about 10 minutes.
Well, can you just say that you have some awesome reverb there?
Thank you.
I'm gonna let Gian answer this in his talk. I probably scooped Gian enough on showing off the new styling, but obviously I couldn't not show it off because it's so in your face. But I know that the new styling is Gian's most favorite feature as well.
Okay, thank you.
Anyone else? All right.
Cool. Thank you, everybody.
Go ahead.
When would this be officially released, approximately?
You know what? We're on a roll here. I'm going to let Gian answer this as well. We're currently working through the release process for Druid, and it's really on the cusp of it. But Gian,
do you know if this stuff is slated for 0.2.1? It is, right?
Everything I showed, I literally for this demo I built 0.2.1. I built the branch.
Got it.
This is everything I showed here is 0.2. I was like, at first I built master and I was like, no, what if I accidentally show something that's not in 0.2.1? What I'm showing right now is probably byte for byte what's going to be released, or almost byte for byte what's going to be released.
Close. Yeah. Yeah, probably a week or 2. Like Vadim said, it's the codes. 0.21 is code complete right now, and it's just going through final testing and all that.
Sounds great. Thank you.
All right.
Awesome. Thanks again, Vadim.
Thank you.
All right, we'll move on to our last talk from Gian. He's going to be sharing those all-important Druid roadmap updates. I'll let you take it away.
All right, let's turn on my camera. Okay, cool. Hey, everybody. So yeah, I'm Gian. Nice to see you all here. Gian at imply.io and apache.org. At Imply, I am a co-founder and Druid person, and at Apache, I am also a Druid person. I'm the chair of the Apache Druid PMC and a committer. So let's talk about how we're thinking about where Druid's going. So there's three things we care about that are our values. Number one is performance. We want it to be fast, and performance has always been number one for Druid. It's the reason Druid exists, and it will always be number one in our hearts and our minds. Another value, the very first version of Druid, for some of you that have been around since the beginning, since the very early days, the very first version of Druid didn't support SQL, didn't support the ability to group by more than one column at a time, believe it or not, didn't support expressions. Very, very little functionality supported, but there was a core there of very high performance that we then built additional functionality around. And Druid of today bears almost no resemblance to that original prototype. Druid of today does speak SQL, speaks actually, I think, more SQL than it doesn't at this point. And we are well on the way to full SQL support. And then finally, operations. Operations making things really nice and smooth to run. And there's a little picture, and a river is a good metaphor, I think, because of two things. One is that operations is about having things be flowing smoothly, like a river. And also, this is a very tranquil photo, and having good operational properties makes your life tranquil because you don't have to worry about things all the time. So, I'm going to keep this brief.
Deanna, are you sharing your screen?
Oh my God. No, I'm not sharing my screen. Thank you. Host has disabled participant screen sharing. Can you please let me share my screen, Yelena? Or Vadim, or whoever's hosting? Thank you. Oh my God. So, okay, you guys didn't miss that much. You only missed some like cool photos that I had that I got from Google Images like an hour ago. But thank you for pointing that out. Now, can you see my screen?
Yep, we're good.
Yep. All right. We're gonna rewind to see the cool photos. All right, here they are. There was a cool rocket car. There was a toolbox, which is boring, but that's what functionality is all about. And there was this tranquil river photo that I was, good thing that I had all these things to say about it, because that's what enabled us all to realize that I wasn't actually sharing my screen. Moving on to the actual content. Like I said, I'll keep this brief. So I just want to talk about some things that have happened in the most recent releases. This is a selection of stuff in these three themes over the last 3 releases or so. And then on the next slide, I'll talk about what's happening in future releases, the next 3 or 4 releases. Okay, so recent releases. On the performance side, there's a lot of stuff here because, like I said, we love performance. We care so much about it. Vectorization enabled by default for time series and group by queries. That was a couple of releases ago. It's a 2 to 5x performance boost for a lot of the queries that we tested it with. Vectorized expressions. So the ability to use vectorized queries even if you're using expressions. We went from having no expressions to having an expression engine that worked and had some overhead to it, to now an expression engine that is very low overhead and fully vectorized. So awesome. Roaring bitmaps enabled by default. That's as of 1 or 2 releases ago. That's really big. It helps a lot for index and filtering operations for high cardinality columns. So if you're not already using roaring, check it out. It's great. Query laning and prioritization, something that enables, so the folks at Target presenting about their situation where it's very rare that a query takes more than a second. That's great. If you've got the scale of cluster to enable that, your life is easy, performance-wise and operations-wise. Not everybody's in that bucket. Some folks have a situation where some queries are sub-second and some queries are operating on tables that are a little bit too big for the britches of the cluster and take more than a second. It might take 10 seconds, 20 seconds, something like that. So query laning and prioritization helps weave those workloads together by having a fast lane, a slow lane, setting up priorities such that the slow queries don't steal resources from the fast queries, and we keep the fast queries going fast. So if you do have a heterogeneous workload, check that out. And then hash-based segment pruning. We've always supported range-based segment pruning, and we recently added hash-based segment pruning to make sure that if you're getting partitioning or isolating the proper data really quickly. Moving on, functionality. We added a lot of cool SQL stuff in the last year. We added joins, we added grouping sets, we added the ability to do subqueries everywhere, and we added the ability to do inline data sources. So Vadim demoed inline ingestion, just pasting some data in. Inline data sources, the same thing on the query side. On the query side, you can actually, you don't even have to ingest data. You just put it in the query. It's pretty cool. And then on the operations front, a lot of the stuff there is about robustness for ingestion. So native batch ingestion robustness, split hints, automatic shard determination, trying to remove tuning parameters. A lot of what we're doing there is trying to make things such that when you are doing those native batch ingestion jobs, that there's fewer and fewer parameters you need to specify. And supporting all partitioning schemes for auto compaction. Auto compaction itself being a feature that I don't think was in the past year. I think it was a little more than a year ago that we introduced that. But now it supports every possible partition scheme, which is great. Okay, so this is all in the past. I'm here to talk about the future. Let's talk. This is the recent past. So if anyone's on a version that's more than a year old, you're missing out on all this stuff. But let's talk about the future now. Looking to the future, all the pictures are the same because the things we care about don't change that much. We always care about these three things, but the items do. So on the performance side, full vectorization. So vectorizing the remaining query engine. The big one is top N and scan are not vectorized yet. So full vectorization. For the group by engine, we want to implement a streaming group by. So right now we have array-based group by and hash-based group by. But if you're grouping by the same column that your segments are sorted by, you could in principle do a streaming approach. And so we'd like to do that for those cases. And reducing thread contention, making it so this is something that doesn't matter very much if you have relatively small servers, but if you have really big servers with 96 processors or whatever, then there's so many processors that thread contention can start to be an issue at those very large server sizes. And we've got a bunch of ideas for how to reduce that in future versions. Indexes for numeric columns. Right now, string columns are indexed, numbers aren't, enough said. Sorting by dimension and not by timestamp. Today, everything is always sorted by timestamp in Druid. But for IoT and sensor data, you actually want to sort by dimension. You want to sort by the name of the time series or by the sensor that delivered the data and put all the data for the same time series together. So for that kind of data set, we can get performance boost by sorting by dimension. You actually have there's a pretty cool workaround you can do today where you set your timestamp equal to the segment granularity. And then you have a secondary timestamp that's the real timestamp. And for IoT data, this actually speeds things up by almost 10x, which is really cool. And a little bit fiddly to get done because you end up having two timestamps and doing funny things with query granularity, and your queries look a little weird, but it's 10 times faster. And anyway, we want to make that possible without having to do all these funny tricks. Moving on to functionality. Someone asked a question about joins. Today we do have joins in Druid. We shipped it within the past year. And the join functionality we have today is really designed for a star schema type situation and for joining against subqueries where the subqueries are modest size. So, for example, let's say you want to do a subquery that selects 10,000 user IDs and then filter on those 10,000 user IDs. The join system we have today is perfect for that. Let's say you want to use a join to implement a star schema where the right-hand side dimension tables are whatever they're going to be. Works well for that. What it doesn't work as well for is a fact-to-fact join or a join against a really massive subquery that has 20 million rows or whatever. So that's something looking towards the future that we'd like to do. Ever larger subqueries as well. So the subquery system right now, like I mentioned, works really well when the subquery results are relatively small, but we would like people to be able to do subqueries with massive results and still have it work quite well. And the window functions and aggregations. Don't support them today, but they're really useful for stuff like moving averages, cumulative sums, percentage of total, so on and so forth. And so we want to add those. Finally, on the ops front, what we call the big indexer. So those of you that are deploying Druid today know that when you, the way that ingestion works is you have there's basically a task system where ingestion tasks run, and each task has its own JVM. And this is really good for isolation, but it is not good if you have a lot of really small tasks, if you want to load a lot of small tables at the same time, that kind of thing. So for those kind of situations, we are redesigning the system such that there's one JVM that can run a lot of tasks in the same JVM, being better usage of resources, share resources better. We call it the big indexer. It's actually in Druid today. The next release, 021, is going to fix the last remaining known critical, I would say, like blocker bugs with it. There's still some feature gaps that we're not going to make it the default in 021, but you can start playing with it in 021, and it does work, and we are using it in production at Imply. Simplified memory management, moving more things off heap. That's part of that concept of having fewer tunables. And simplified native batch tuning, fewer tunables, trying to get all the way down to 0, or as close to 0 as we can get. All right, that's it for the roadmap. I want to say one last little bit. I am Druid, so can you. How you can get involved, and Miguel talked a bit about this. I'm just going to add a little bit more. You can go to the Druid community site, druid.apache.org. Of course, I work at Imply. We have a distribution of Druid at imply.io/get-started that has a bunch of extra goodies in it. We have Druid University at Imply, imply.io/druid-university, where you can learn about Druid if you're new to it, introduction to a lot of the basic concepts. We're on GitHub, it's open source, give us a star. And follow us on Twitter, mailing lists, Slack, meetups like this, events like this, all announced through community channels. And there's a new, very recently launched unofficial Druid forum, www.druidforum.org. Check it out, get some help and talk about Druid. Thank you for coming.